Thank you. So he can give an update there too, because what NewScale's been doing has really been important, and I think it's very pertinent for this audience. So we'll start. So first of all, you're from past things, we're in the process of subscription, and it's not, it's sort of a slow process. It just takes, this is new technology, first of a kind, coming across, and it just takes a lot of time working with the public to get this socialized and in place. But right now we're approximately 4 modules, 5, if you will, out of the 12 are set to go. 2 of them are really focused towards the Department of Energy and here at the lab. So one, as Bob talked about earlier, is the JUMP module, the Joint Use Module Program, that is going to be used for research. But for us, that's very important for risk reduction. This first-of-a-kind risk reduction is to get this through, and NewScale needs somebody to start the process going for them and get this in. So it's going to help us that not only is it going to help with other R&D that's going to go along, specifically hydrogen production is a big thing that we're very interested in as well, especially if you're going to be looking at compressed air type storage systems. Instead of using methane to fire up the generator, you use hydrogen, and that can meet the California needs as well coming in. In our membership, we're right now at 124. We've got a couple of members coming up. I'll remind you that we're sort of looking for a magic number of 150 out of our membership. I think that'll probably be done the end of June, possibly the end of July. It could be a little slop over there. We'll be ready to go on that. One of the reasons that we've been able to pick back up subscription is that we can now show that we're very competitive with combined cycle natural gas plants in terms of where we're shooting. So we're shooting in a range, somewhere between $45 to $65 is a big range out there. We're focusing at $55 a megawatt hour onto the grid right now as our shot, and that's very competitive with combined cycle natural gas. We beat the pants off of batteries or anything else on any other storage system that goes with renewables, and we interact with renewables really well going through. And I think that, just again, a shout out to DOE sponsoring Module 1. And then, as Bob mentioned earlier this morning, we are working with Idaho Power Company to facilitate servicing the site. Obviously, Bear Prairie's here and the mayor's here. They're going to be servicing this place here, so they'll have power coming through both of those. I'm not going to, you're probably well aware of this. This is really DOE is carrying the water on this, but I'd just like to mention, I was hoping that Chairman Small would be here, but he's not. And going through, but we are working closely in conjunction with the Showban in terms of the site. If you know, you're probably familiar, we were looking at a site that was south of the facilities out at the lab out there. We've now, this was due to seismic and volcanation calculations, we've now looking at what we're referring to as Site 3. It's a little further to the west, going up over towards the Lost Mountain range over there, closer to Arco, if you will. And it does have some sensitivity in terms of artifacts and things of that nature, and we're going through that consultation with the tribe. Also, we're really interested in promoting and this will be good for everybody down here. One of the things we see when we put this in place is we're going to be able to carry this load in a black start mode. So Southeast Idaho is going to have a huge benefit. Specifically, I can definitely tell you without having to do any studies, we can pick up basically from Pocatello all the way through Idaho Falls and St. Anthony and the southeast area. We might be able to get even further down south and the east in terms of, if we lost the grid, a national brownout center, that the minute the grid comes back, we're going to be ready to generate, because we don't need a black start cable. We don't need the grid to keep us alive and well. We get power down to 1 module, down to a level that would give us the site load. And then the minute the grid's available again, we can bring up 720 megawatts of power into the area. And then we can set the transmission system to keep it open so that we can service this area in southeast Idaho. We pointed this out to the tribe, but for the county, that this is a huge economic development potential for you, because you could bring in very electric sensitive loads, like, if you wanted to, like server farms, national defense, things of that nature. It really brings in a new dynamic that you really can't do with other types of generation that goes on. I'm going to turn it over to Chris Colbert right now and let him.
All right. Okay, can everybody hear me all right? Sounds okay. So I just got one slide here. I don't know why I took this from Doug, because I don't really need it beyond just talking to this slide. But I want to hit on the three things that really have been front and foremost for Uamps and other customers. They talk about the potential for small modular reactors, what NuScale is doing, and really three buckets of the NRC licensing progress, supply chain, and what the market outlook is for what we're doing going forward. On the NRC licensing progress, we submitted a 12,000-page document back at the beginning of 2017. 2 months later, the NRC accepted our design certification application for review, and they established a schedule that would have us getting our design certification, what they call their Phase 6, by September 2020 of next year. What we've been able to do is, through that process, is that the NRC has actually managed to keep onto that schedule. In fact, we think they're a little bit ahead of that schedule, but they have not identified anything of a major issue or challenge for us to get through that process. So one of the key risks that people had, and I'm sure the Admiral will probably share with you at some point, of one, could NuScale actually put together a design certification application in time? We did it. Second, could the NRC actually review it in a timely manner? They are doing that. So we're very comfortable where we are with the NRC. Just to give you a few metrics, I mentioned a 12,000-page application. In the first year, they asked over 1,500 questions to us. It's called Request for Additional Information. Spent about $20 million, about 10,000 hours of staff time putting those questions together. We narrowed that down to 29 issues over time, and by the end of this year, we'll be at a point where we'll have an advanced safety evaluation report with no open items, meaning there's nothing left to do except to turn the crank and make sausage. So we're doing very well in that process. And that bodes well for Uamps, because they're going to have to go through a licensing process as well. And knowing that you can get through the NRC in a timely way is very important for them and for other customers. Supply chain development, John Wagner mentioned today, there isn't an SMR supply chain per se. There's not a microreactor supply chain. But because of our design and because of the size of the components that we have, much of the existing large reactor supply chain is applicable to what we're doing. So we made a very conscious decision to make sure that we weren't going into areas of unique materials or applications that weren't known or proven by the NRC or by industry. So in the supply chain, for example, Riva is going to be our fuel supplier. They actually built 2 fuel assemblies for us out in Richland, Washington. We tested them, we demonstrated that they work. Not with real fuel in them, but all the other characteristics we need. So that's a key element for any reactor design, is the fuel. So we're using a proven fuel design, a proven fuel vendor, and we've actually built a couple of the fuel assemblies. We announced middle of last year, we selected BWX Technologies to be our U.S. partner for the design for manufacture of the NuScale power module. So going from what we have with the NRC, which is the number of drawings, getting into the detail of actually how do you break that up and how are you going to fabricate these items as part of your equipment. So that was a very important development for us. Just 2 weeks ago, we announced a memorandum of understanding with Doosan Heavy Industry and Construction. They're a group that can do also the NuScale power module, because as I get into market outlook, our goal is not just to supply the United States with NuScale power modules. We want to export these globally. And we think the market for the NuScale power module, probably 3/4 of our market, is outside of the United States. So having that ability and having a global supply chain where we can supply the U.S. and other parts of the world and do it quickly and scale rapidly is an important aspect for us. And the fact that Doosan is coming in not only as a manufacturing partner for portions of the NuScale power module, but also as an investor, is a key indicator of the belief that the international market has in our technology. And then finally, in the market outlook, Uamps is our first project. That's the important thing for us to get done. Without that first project, nothing else is possible. In fact, whenever we talk to anybody, they're very keen to be number 2. They want to be as quickly as number 2 as possible, but they want to make sure that these guys are going forward. And so the importance of Uamps and Department of Energy taking those first 2 modules is critical to our success. But as a result of that, we've had a number of announcements recently with other entities outside the United States, 2 in Canada, 1 in Romania, 1 in Jordan, and selecting our technology. And again, they don't want to be the first, they want to be the second, and they're coming out to see how this goes. In fact, next week, you'll have the representatives from the Jordan Atomic Energy Commission coming out to visit INL. They're the entity that is down selecting SMRs for application in Jordan, and they'll be coming out to visit NuScale afterwards. I think I quipped at one point that once you have this plant operational in Idaho, you'll really need to beef up the international terminal at Idaho Falls, and I think that's just going to be the beginning of what you'll see people coming out to see the technology in operation and demonstration for it. So that is really my update on that. I'll turn it back over to Doug. And I never needed that.
You never needed it. That's okay. It's a good crutch. One of the things I really wanted to talk to you guys about is our movement to looking at cooling the steam cycle. This is not the reactors. It's not anything to do with that. This is just on the electric production side. As you know, these are typical Carnot engines. You have to have a cooler exit temperature than you do. You're starting to get the work done out there. And typically at a power plant, we would use water and run it through a cooling tower and evaporate it to get that delta T, if you will, out there. One of the things that we were enthused with is the size of these reactors. We felt that it was possible that we could go to dry cooling, that is using air condensers instead of a wet condenser. You can see that there's a ton of benefits associated with that from a social point of view, obviously. Water, even up here in Idaho, you have a lot of it, but Utah, Nevada, New Mexico, places where our customers sit, it is a dear type of a commodity, and it's very, and it is fully allocated up here as well. So we embarked with power engineers here in Idaho to go over and look at the initial study. It's going to sound a little funny, but we're now on our 4th iteration of this engineering study because this is a very critical decision for us to make. This is not trivial whatsoever. It'll impact the design of how we set the site, how we do our COLA application with that, and we have to work with NuScale to make sure the engineering's correct and things of that nature. So we're on our 4th iteration. We're now through our 2nd. We started with power engineers. They did the initial study. We had them go back and do another run through it based on things. We've now taken it through the Tennessee Valley Authority, have their review because we're working with them on a combined construction operating license application with the NRC. And then we've also retained Sargent & Lundy, engineering firm, and they're on their 2nd run of this study right now. Everything's indicating, though, that we're probably going to go dry. We're going to go to air condensers instead of wet. It's economic. One of the things I deal with a lot of local governments and that, and we have to be very cautious about money to go through and not put them in a bad position that way. But right now it looks like it's going to be less expensive to go to air condensing than it would be dry. And one of the things, though, that I'm sure all of you would just come right off is what happens on a hot, muggy day if you're using air that like a swamp cooler doesn't work as well in a high humidity thing. We will lose output on those peak hours. But one thing to keep in mind is that the electric market is changing, and it's changing quite dramatically in terms of pricing. We're used to having high prices in the middle of the day. This is when normally everybody expects the price of power to be the most expensive. But due to net metering and solar, for the most part, that curve is changing on us. And so in the middle of the day, we're getting overproduction of solar, and this is happening in spades, if you will, down in Southern California and Southern Arizona, but it's starting to creep everywhere. There's more and more solar coming on. And so the price of power is going to be more expensive in the night and in the wee hours of the morning than it's going to be during the very hot parts of the day as we see this go through. And so the loss of that parasitic or that efficiency loss that we lose on this curve, we could purchase that at basically the same price if we wanted to make up for that. So that was part of the economics that we're looking at. The main thing is we want to make sure the thermodynamics work. Just in general, one of the things, and I'll talk about in just a second, is the ability to match with these renewables, these variable resources, energy resources out there. And so what we want to be able to do, one of the things we wanted to be able to do is besides move the reactor, there's certain, we can do that, but we'd rather not as much. One of the things we want to do on instantaneous load movement is bypass the steam generator and move our steam directly to the condenser. So if you think about this, this is, high pressure, high temperature steam, and there's a good amount of volume to it. And basically you're just sending that steam up against a big metal plate, just to get that in your head. That's what you do, you slam it up in anything and bypass the steam generator. Well, with an air condenser, that's a little different. The condenser looks a little different, and we have to look at that engineering to make sure that those costs are in line. But right now, it looks like that's where we're going to go. And you can see up on the slide, it's a significant reduction in water usage. The 2,000 to 3,000 acre feet, that's just for site and normal stuff that we'd be using it anyway out there. But we can avoid 10 times that amount by going wet. Now, we haven't made the final decision, but I've got the chairman of my project management committee sitting right over there, and he knows it's coming up. We're going through this, but like I said, we're doing it very cautiously. We're just doing a lot of engineering to make sure we've got this down. So, but I think it's the biggest thing, and it is going to be less expensive. It's not in the scope of this this project. I'd say it's $60 million less expensive, but that's really not. When we're starting to talk about, we're in the billions, obviously, in this thing. But it is to the better. Again, we hit this, but I really want to accent this because this is something that we're really trying to do on an educational basis with public service commissioners, politicians, if you will, elected officials, and so they can start to understand this. We're seeing this big trend. The state of Washington just passed a 100% clean bill. California's already had theirs in. New Mexico just passed a 100% clean bill out there, and we like the term clean energy versus renewable energy out here. And one of the things we're finding out is that people they really do believe you can run everything off of renewables. I don't know how many people I talk to have solar cells on their house, and they really think those solar cells are running their house. It's really not. The utility's running the house, and they're just pumping energy back into the system. There's just not the capacity component. You can do it. You can do it with batteries. You can back it up with gas, natural gas. You can do a number of things. We think we match up even better than that to go through because we can move these up and down. Like I said, we have a ramp rate about 20 to 60 megawatt range on the reactor itself. They're on a relatively good thing, or we can just simply, as I mentioned, bypass the steam generator and just go instantaneously. And we've done a study on our wind farm. Wind is the most unpredictable variable resource you can deal with. It's solar, the sun's shining, you're getting solar. If it's not shining, you're not getting it. Pretty easy to predict. Wind, it just comes and it goes. And we do have a lot of it in the Northwest. You'd be surprised. There's almost as much wind capacity in the Northwest as there is hydro capacity now. It's a big deal up here in this rain out here. The other thing is it allows us to decarbonize and start to talk to everybody. This was mentioned earlier how industry, Mr. Kotek was talking about that earlier. And we are seeing that. There are a number of industries that want to be 100% clean, and they're starting to grab onto the intellectual benefit of nuclear instead of batteries or anything like that, mainly in costs, and we've been able to demonstrate it through. So this, again, will be a big economic driver for us to be able to allow people to take 100%, and I've even told people, I don't care what renewable portfolio standards you want to pick. I mean, there's all these numbers, 60, New Mexico's 80% are renewables. And that's fine. They can go for those. It's aspirational in all of these things. It's really difficult price-wise to get past 30% of your portfolio as renewables. Because if you think about it, you've got to add so much more capacity to the system to back up those renewables. The more renewables you put in the portfolio, the more capacity you have to build someplace else in either the form of batteries, which are not renewable, or in terms of other generation. We match up for this just perfect in this. And then I'll just go one step further. Idaho Power's in this, so you're aware of this. Rocky Mountain's in it. It's called the Energy Imbalance Market out of the California Independent System Operator. And this is right now is basically a 5-minute look at the system all the time with a 15-minute redispatch of our generators. This is really wears out our gas machines. Our coal plants really can't follow. We got to, basically what we do is we just run them down to minimum, keep them hot, and then run them up again. So there's a lot of fuel being wasted into the system while the renewables are coming. Here with these reactors, we can really match that up and do that at a much lower cost out there. So let's see, I think I've just got, and then I'll just end it with this slide right here. It's always a shout out. Just make, you've got great delegation here, but we always working on this. The NELA, the Nuclear Energy Leadership Act, this is very, very important specifically for this area here. Right now, the labs are constrained, all the national labs are constrained on the length of a contract term they can sign for power. We want to do 40 years worth of bonding on this. This is what we're going to do. It's going to be debt driven, our project. We'd like to do 40-year bonds, if you will. So we would like to see a contract with INL for 40 years. That's what we'd really like to see. That'll be lower cost for them as well. They don't have to go through, and it would take out risk for our guys. And so NELA does that for us. It does other things, but that's the one thing it really does. Right now we're working between Idaho Power Company and Western Area Power Administration, because Western Area Power Administration does have the ability to go out longer. Not even Bonneville Power Administration has the ability to go out past 20 years, so that's very important. And then, of course, the storage legislation, it hasn't been introduced yet, but it is starting to work its way through, and you go on that. So with that, I think that's all I've got there, Bobby Jo.
Thank you. Are there any questions for Doug or Chris? Great. Thanks, guys.